All right, guys, this is your intro to setting up your notebook for lesson 3.1, the force of a rubber band. So on the right here, you will see how your notebook needs to be set up. If you need to zoom in on this, the PDF is attached on Schoology, so it shows how all of this goes in. Notice you've got the sheet flipped over to the left-hand side of the page there, so that'll flip back. So once you get your page set up like it is on the right, look over here on the left, you're going to put a little piece of tape here, here, and here. Make sure you don't tape down the corners like you shouldn't do. Again, if you tape it down correctly, it'll flip back and you can see your page under it where you're going to have answers to write. And you'll also be able to access the back of the student sheet. So if you need to at this point, pause this video and get your notebook set up so that you will be good to go. All right, so this is lesson 3, the force of a rubber band. So introduction here at the bottom. Trampolines are a lot of fun. What forces are at work as you bounce up and down on a trampoline? You just investigated one of these forces, gravity, in lesson 2. In this lesson, you will investigate another force that also makes it possible to have so much fun. All right, guys, so the objectives for this lesson are as follows. Describe the nature of elastic forces and how they act on objects. Determine how the force a rubber band exerts is related to its stretch, and to use data tables and graphs to interpret data. So let's look in your notebook. At this point, you should have your learning targets set up. So we reworded these, so they are in I can statements. So read along with me in your notebook. I can explain how elastic forces work and how they act on objects. 2, I can determine the force exerted by a rubber band based on its stretch. So remember this as you are doing the lab, you will be assessed on the learning targets. All right, so let's also remember our claim for this lab, because remember, at the end, you're going to have to go and defend your claim that you made with evidence that you gather from the lab and reasoning. So the claim, the farther you stretch a rubber band, the greater the force the rubber band will exert when released. So again, make sure that's in your notebook so you can refer back to it later. All right, so this is the getting started section. So in your science notebook, write what you know or think you know about forces that are stretchy or springy. So take a moment, pause the video, and write about that in your notebook. All right, also list some places where you see these kind of forces in action. So again, pause the video and add that to your notebook. All right, so some answers you may have given. Trampolines, a lot of people talk about the jump park here. Where else would you see those? All right, so if you have anything else, just make sure you write it down and you can add that to the discussion board post that will follow in the future. So in this lesson, you will use a spring scale to measure the force of a rubber band, but you will hold the spring scale horizontally instead of vertically. So in the previous lesson, you've held the spring scale vertically to measure weight. This time we're going to be doing it horizontally, like going flat on a table. So before using the spring scale, you have to make sure it's first properly calibrated or set to 0. So remember, your red dot has to go to the lines pointing to the 0 mark. For this lab, since you're virtual, you will just be observing still images on the screen and making note of what those are on your student sheet. So we will continue on the next slide. All right, so we are in the procedure section of your notebook. So make sure you're under procedure number 1A and B. So hold a rubber band at one end and with a finger on your other hand, carefully stretch the rubber band far enough to feel a force of the pull. After doing this a few times, answer the following questions in your science notebook. So if you are at home, go grab a rubber band and give this a shot. When you stretch the rubber band, what do you feel? So that's A. So pause the video and make that observation in your notebook. What do you feel when you stretch the rubber band? All right. B. In what direction does the rubber band pull your finger? So if you need to go and do that again, grab the rubber band, stretch it, make that observation, write it in your science notebook. So pause the video here if you need to do so now. All right, number 2, repeat step 1, but pull a little harder on the rubber band. Answer the following questions. All right, 2A, now what do you feel? All right, pause the video and give that an answer. All right, B, what happens to the rubber band when you pull a little harder still? All right, so let's look at these. So 2A, so you're going to feel that the rubber band is exerting a force. Sorry, that was 1A, that you feel the rubber band exerting a force. 1B, the rubber band is going to pull against you as you stretch it. So if you're exerting a force on the rubber band is exerting a force back on you. All right, 2A, when you pull harder, it pulls harder back on you. B, the farther you stretch the rubber band, the more force you apply, and vice versa, the more force it applies on you. All right. 3, and you don't have to write anything down for this. Just take a moment and think about this since you're not in class to discuss with the group. How could you find out how the force of a rubber band changes as the rubber band is stretched? So take a moment, think about that. All right, so if you look at number 4, there's an image at the bottom of the page there. This is showing you how your lab is going to be set up. You're going to put a meter stick at the center of the table, and you will have a rubber band in the center. And the next will follow on the next page. All right, so we will continue the setup for that on the next page. All right, so before we go any further on the lab procedure, let's review reading your scale. All right, so if you notice here, this scale isn't properly calibrated because the little red mark here does not line up with 0. So we would have to calibrate this before we're able to get started. All right, so remember, pounds is not a unit of force here. This is weight. So pounds would fall under the category of weight. Newtons are what we use to measure forces. So that's what we're going to be concerned with in this. So when you're reading the images on your spring scale, you are looking at the Newton side of the scale. All right, so we're not concerned with the weight side at this point. So let's look specifically at the Newton side. All right, so between each numbered increment, you have 4 steps. So 1, 2, 3, 4. So if you divide 4 into 1, you're going to get 0.25 as your increment. So each of those little dots are worth 0.25. So this first one is 0.25, the next one 0.5, the next one 0.75, and the next one would go to 1. So continue that trend as you go down for reading the scale. And if you need to come back to this section of the video to review this, that is not a problem. Do so as needed. Okay, so now you can see how the rest of the lab is set up. You'll have a second meter stick. We're using a ruler here because we don't have enough meter sticks. And this is what you're going to measure. So you'll hook the spring scale to a rubber band, and you're going to pull it back by increments of 2 centimeters and take readings at each. So when the rubber band is stretched to 0 centimeters, you'll make your mark here on your student sheet. When it's at 2 centimeters, 4 centimeters, 6, and so on and so forth, all the way down. Once we finish taking our data, we're going to go and look at questions that you see at the bottom of the page and on the second page of your student sheet. So we'll get to those once we actually take the data. All right, right, so before I play the video, this is just kind of giving you a visual of what I've explained how the lab's going to be. You don't have to take readings here, but this is kind of how the lab would have progressed if you were in class. All right, guys. So on this is going to be an inquiry looking at elastic forces. So we're going to begin. We've got our setup here. So you're going to see a series of pictures taken where we have stretched the rubber band using the spring scale so that we can measure the force at each distance. So we're going to start with a stretch of 0 centimeters, and we're going to take a reading every 2 centimeters from 0 all the way to 20. All right, you're going to make those observations and write your data in your student sheet on table 1. So again, you're going to see photos where we've stretched the rubber band, and you're going to see images of the spring scale like you see here. So you're going to make note of the reading on the spring scale at each distance, and then you're going to use that data to answer some questions. All right, guys, so on this section, we're going to be looking at the individual measurements taken at each of the sections where we stretch the rubber band a given distance. So remember, you're using your student sheet that you see here, and for each number, I already have it marked off. So as you see here, I have it labeled for each stretch done. So I'll zoom in on each, and I'm going to cut the mic off. So as we go to each, just pause the video and make your recording on your student sheet. There's not going to be any sound for the rest of this little section as you're just reading these, just so there's no background noise. So pause the video as you need to on each reading and progress as quickly as you can. All right, so number 9 and number 10. Number 9 is going to look at number 1 on the student sheet. We'll look at that in just a moment. Number 10, you're going to be graphing what you see on your table 1 on your student sheet on the second page. We'll look at that in a moment. And then again, number 11, those are also answers on your student sheet. So we'll be looking at those individually. So let's go through this. So number 1, you need to have this table here completed. If you don't, you need to go back and get that from earlier in the video where you had the different spring scales on the screen and you had to record the measurements for each. All right, but we'll look at a couple of them before moving on. So for 0 centimeters, you should have a stretch of 0 centimeters, and your force reading for 0 centimeters would have been 0 newtons. All right, for 2, I got 1.4 newtons, but yours might have been something different. So continue that all the way down. All right, so number 1, look at your data that you got here. So make an observation and write what happened when you doubled the stretch distance. So what happened at 2 centimeters and 4 centimeters? Describe what happened with the force when that distance doubled. All right, in another sentence, describe what happens when you went from 4 centimeters to 8 centimeters. And then a third sentence, describe what happened when you went from 10 centimeters to 20 centimeters. So keep these very simple and just describe what happened. All right, pause the video to do that if you need more time. All right, so number 2, you need to construct your graph. So I'll give you some help filling these in. So your title needs to be descriptive and talk about what we're doing. So I would call this title Force versus Stretch. So Force versus Stretch. If you've already titled this and it's something similar, that works. All right. So you're going to have two axes here. Your y-axis gets your dependent variable. Your x-axis gets the independent variable. So your independent variable here will be stretching distance. So that'll be your title for this. So make sure you say stretching distance. And then your dependent variable is the stretching force or the elastic force. All right. So yours may be different than mine, but we're going to go back at 0, 0. So at 0 centimeters, I had 0 newtons of force. So I will have my first dot. No, that one messed up. There we go. So my first dot will be there. And then if I graph my second at 2 centimeters, my elastic force was 1.4. So again, I go over here. My stretching distance is on the, let's see, horizontal axis here. So let's pause with the data and let's put some labels on here. I'll help you guys with that. So we said this is stretch, and this would have been force on this side. All right, so now let's put some labels down for this. So on the x-axis, we're gonna go 2 centimeters, 4 centimeters, and I'm just gonna do numbers for the rest so that it doesn't get too congested. All right, and then on the y-axis, we're just gonna go up by 1. All right. So at 2 centimeters, I had a force of 1.4. So I'll go to 2 centimeters, and then I'll go up, and my first point after the 0 centimeter stretch would be about here. All right, so you'll use the rest of your data that you have in this table to finish graphing your points. So just as a little review, when you're graphing this, you'll go to 4 centimeters and you'll go up to whatever your reading was. At 6, you'll go here and go up to whatever your reading was. All right, so let's look at the rest of these. Number 3, what does the graph tell you about the relationship between the force needed to stretch a rubber band and the distance that it stretches? All right, so as you stretch the rubber band, what happens to the force that it exerts? All right, 4. And of course, guys, as you need to pause the video to answer questions, pause the video. So 4, did the force needed to stretch the rubber band increase by the same amount each time you stretch the rubber band another 2 centimeters? Also, is the answer visible in the graph? So look at your data and come up with an answer there. All right. Finally, can you predict the force needed to stretch the rubber band to 40 centimeters? Why or why not? All right. So pause the video if you need any more time to answer any of those on your student sheet, and we will go to the reflection questions in our notebook. So you will answer these in the reflection section, or the reflecting on what you've done in your science notebook. So in your science notebook, answer these questions. 1A, you want to pull a cart along the floor. How would you use a rubber band to do this? All right, pause the video, answer the question. B, suppose you want to apply a force twice as big as the one you want to use for question 1. What would you do to the rubber band to produce twice as much force? C, how is the spring scale you use to measure force like a rubber band? D, in this inquiry, you examine the forces that pull on objects. Give an example of another way to exert a force on an object. E, materials like rubber bands and springs are called elastic materials. Can you think of other materials that are elastic? And F, review your definition of force that you wrote in lesson 2. How would you define force now? Write a new definition for F. All right, so pause the video now if you don't have those questions answered. We're going to go over a couple of them on in the next section here that'll be coming up in a moment. But if you need to pause anything to answer questions, do so now. All right, so let's go over some of these questions from the reflecting on what you've done section. All right, so A asks, you pull a cart along the floor. How would you use a rubber band to do this? Well, pretty simply, A, attach the rubber band to pull the cart. B, suppose you want the force to be twice as big as the one from question 1. What would we have to do to the rubber band to produce twice the force? Well, you'd have to stretch it twice as far. All right. C, how is the spring scale you used to measure force like the rubber band? Well, the more it's stretched, the more the spring stretches, the greater the force it measures. All right, D, in this inquiry, you examined forces that pull on objects. Give an example of another way to exert a force on an object. So forces can also push objects. So the opposite of pull is a push, because forces can also push. A force is defined as a push or pull. So a force is defined as a push or pull on an object. For the sake of the definition, we'll leave it at that. All right. E. So elastic materials. So a lot of people said rubber, various things made of rubber. Springs are another one that we used in this one. So basically anything made of metal sometimes can stretch depending on how it's made. If it's made of a flexi material, that also helps. If you come up with anything else here, write it down and bring it up in class. All right, F, review your definition of force that you wrote in lesson 2. How would you now define it? Well, at this point, you should be able to see, or starting to see, a force is a push or pull on an object. So very simply, all you have to have is your definition was either right or you were wrong, and the definition that we're currently going with, based on your current understanding, is a force is a push or pull on an object. All right, so that will wrap up this lab. So make sure you have everything complete in your science notebook. The reading selections that follow will be on the same topic. And if you have questions, guys, please shoot me a message at Schoology. You guys have a good day.